Close your eyes, take a deep, slow breath. Feel the weight of the world slowly slipping away. We are about to embark on a journey far beyond the noise of the city. We are leaving the earthly concerns behind. We are traveling into the vast, silent ocean of the cosmos. Imagine holding a tiny, wooden match in your hand. It is such a simple, ordinary object, yet it holds the potential for light and warmth. Now, imagine floating in the absolute silence of the cosmic void. A grand paradox awaits us here. Can something as simple as a match ignite in the infinite dark? Today, we will explore this beautiful mystery. Let the gentle rhythm of the universe calm your thoughts. We will uncover the secrets of fire, space, and distant worlds. You are safe. You are weightless. Let us begin. Before we journey to the stars, we must first understand the ground beneath our feet. What is fire? On Earth, fire is a living, breathing entity. It is a rapid chemical dance. It requires three fundamental partners to survive. This is known as the fire triangle. First, there is the fuel, like the wood of our match. Second, there is heat, born from the friction of a strike. And third, there is oxygen, the invisible breath of our planet. For millions of years, earthly fire has illuminated the dark. It has warmed our ancestors. It has shaped human history. Our atmosphere, rich with 21% oxygen, is the perfect cradle for this glowing phenomenon. Gravity, too, plays a silent, crucial role. It pulls the heavy, cold air down. It pushes the hot, light air up. This invisible current is what shapes a flame. It stretches the fire into the beautiful, flickering teardrop we all know. But what happens when we take this delicate earthly dance and throw it into the infinite expanse of the universe? What happens when the rules of gravity and air no longer apply? The answers are more magical than you might think. The anatomy of a spark. Let us focus on the match itself. Feel the rough texture of the striking surface in your mind. This is where the magic begins. On Earth, striking a match creates a sudden burst of friction. Picture a microscopic landscape of jagged peaks and valleys on the matchbox. As the match head scrapes across this terrain, red phosphorus turns to white phosphorus. It generates a tiny, localized heat wave. This heat is the first spark of life. It is the catalyst that wakes up the chemicals. It is a beautiful illustration of energy transforming in a fraction of a second. The birth of the earthly flame. Once the spark is born, the reaction blossoms. Potassium chlorate inside the match head releases oxygen. It feeds the initial burst of fire. Picture the sudden flare of yellow and orange light. It is a miniature sun bursting into existence right at your fingertips. The wood begins to char, releasing volatile gases. These gases catch fire, sustaining the glow. This is the earthly way. It is a sequence of events so perfect we often take it for granted. But this perfection relies heavily on the environment wrapped around us. The invisible hand of gravity. Why does a flame point upwards? It is a question of gravity. Gravity is the silent sculptor of fire. Imagine a hot air balloon rising gently into the sky. A flame works the exact same way. The heat makes the surrounding gases expand. They become lighter than the cool air around them. Gravity pulls the heavy, cold air down to the base of the match. This forces the hot, glowing gases upward. This process is called convection. It is an endless cycle of breathing in fresh oxygen and exhaling smoke. Picture this invisible current flowing perfectly. The colors of combustion. Look closely at the imaginary flame in your hand. Notice the colors. At the very bottom near the wood, there is a faint blue glow. This is where the combustion is purest. It is where oxygen is most plentiful. Above that, the flame turns a brilliant, comforting yellow. This yellow light is not just fire. It is actually tiny, unburned particles of soot. They are glowing white-hot in the heat. It is a beautiful myth that fire is just pure energy. It is actually a glowing cloud of matter. This is the beautiful, messy reality of an earthly fire. Leaving the earth behind. Now let us slowly leave the surface. Imagine yourself rising above the clouds. The blue sky begins to deepen. It turns into a rich, dark indigo, and finally, pitch black. We are leaving the comfort of the atmosphere. We are leaving the realm of abundant oxygen. The air grows incredibly thin. The pressure drops away. You are entering the silent, peaceful vacuum of space. The chaotic winds of Earth are gone. Here, there is only stillness. It is a profound, ultimate calm. Picture the stars appearing like scattered diamonds on black velvet. The true nature of the vacuum. Many believe space is entirely empty. This is a common myth we must unravel. Space is a vacuum, yes, but it is not a perfect one. It is filled with trace amounts of gas, cosmic dust, and radiation. However, the particles are incredibly far apart. They are too distant to interact like they do on Earth. Imagine a vast, empty concert hall with only 3 people standing miles apart. That is the density of the vacuum. There is no air to carry sound. There is no air to breathe. And most importantly for our journey, there is no ambient oxygen. The chill of the cosmos. Let us address another illusion. We often think of space as simply freezing cold, but temperature in a vacuum is a complex concept. Temperature is the measure of moving particles. Where there are no particles, the concept of cold changes. If you were in direct sunlight in space, you would boil. If you moved into the shadow of a planet, you would instantly freeze. There is no blanket of air to distribute the heat. Picture the sharp contrast between blinding, burning light and absolute, freezing darkness. It is an environment of extremes. The first attempt in the dark. Imagine floating in this infinite void. You are wearing a protective spacesuit. You hold the match. You hold the striking pad. You prepare to strike. But what hides behind this simple action? In the vacuum, the sheer lack of pressure changes everything. The moisture inside the wood would instantly boil away. The match would become incredibly dry and brittle. Picture the wood splintering silently in your gloved hands. The physical integrity of our simple tool is already compromised by the unforgiving nature of the cosmos. The strike without air. You press the match head to the strip. You drag it across. The friction is still there. The red phosphorus still heats up, but there is a crucial missing link. Without ambient oxygen, the chemical reaction is abruptly halted. The match head contains its own small supply of oxygen in the potassium chlorate. This might create a microscopic, instant flash, but without the surrounding air to sustain it, the wood cannot catch fire. Imagine a tiny, silent pop of light that vanishes before it even truly exists. The void consumes it instantly. The silent death of a spark. The spark dies not because it is crushed, but because it is starved. It is a peaceful, instantaneous end. The vacuum does not blow the match out. It simply refuses to feed it. This is a profound lesson from the universe. Even the brightest potential requires the right environment to bloom. Picture the unburned match floating away into the darkness. It is intact, yet forever dark. The myth of explosive space fires is born from Hollywood. The reality is much quieter. It is a silent, graceful failure. A new environment, but we are not finished yet. What if we bring our environment with us? Let us move into the safe, glowing interior of a spacecraft. Imagine floating inside the International Space Station. The walls hum softly. The air is warm and breathable. We have restored the oxygen. We have restored the pressure. We have reassembled 2 parts of our fire triangle, but we are still missing one earthly element. We are in microgravity. We are in a state of constant freefall. Here, up and down are merely suggestions. The microgravity ignition. Inside the spacecraft, you strike the match again. This time, the spark catches. The oxygen in the cabin air feeds the reaction. The flame is born. But prepare yourself for a mesmerizing sight. Picture a flame entirely unlike the one on Earth. Without gravity pulling the cold air down, there is no upward draft. There is no convection. The hot gases do not rise. The flame does not stretch into a teardrop. Instead, the fire expands outward in all directions equally. It is a perfectly symmetrical phenomenon. The ghostly blue sphere. The flame takes the shape of a perfect, floating dome. It is a sphere of fire, and the color is completely different. Gone is the bright, flickering yellow. Space fire burns with a ghostly, translucent blue light. Picture a glowing, azure bubble hovering calmly in the air. It is incredibly beautiful. It is hypnotic. It is a flame that does not dance or flicker. It sits peacefully, radiating a soft, steady glow. This is how fire behaves when it is completely free from the chains of gravity. The science of the blue glow. Why is the space flame blue? Let us uncover this secret. On Earth, the yellow color comes from soot particles rushing upwards and heating up. In microgravity, the soot particles linger. The combustion is slower, cooler, and surprisingly, more complete in some ways. The blue color is the pure light of the chemical reaction itself. It is not obscured by the glowing soot. Imagine looking at the bare, naked essence of fire. It is a quiet, glowing orb of pure energy, floating gracefully in the cabin. The suffocation by stagnation. But this beautiful blue sphere holds a tragic flaw. Because there is no convection, there is no wind to bring fresh oxygen to the flame. There is no current to carry the exhaust gases away. The carbon dioxide created by the fire forms an invisible shell around the blue dome. It traps the fire in its own waste. Picture an invisible blanket slowly wrapping around the glowing sphere. The flame is slowly suffocating itself. The hypnotic blue light begins to dim. It grows fainter and fainter. The quiet extinction. On Earth, a match burns until the wood is gone. In microgravity, the match extinguishes itself long before the fuel is consumed. The carbon dioxide shell becomes too thick. The oxygen cannot pierce it. The blue sphere shrinks. It flickers just once, a silent plea for air, and then vanishes. Picture the thin trail of smoke radiating outward in a perfect, expanding ring. It is a beautifully peaceful end to the fire. It is a slow, sleepy fade into darkness, rather than a violent extinction. The danger of space fire. This slow, suffocating nature of space fire is actually a serious concern for astronauts. You might think a fire that puts itself out is safe. Let us debunk that myth. Because the smoke and toxic gases do not rise to the ceiling, they linger exactly where they were created. They spread slowly, invisibly, in all directions. If a fire starts behind a panel, it will not trigger traditional smoke detectors on the ceiling. Picture a silent, invisible cloud of toxic gas slowly filling a zero-gravity module. It is a hidden, quiet threat. The artificial wind. To combat this, space stations are equipped with constant, artificial ventilation. Fans push the air continuously. If you light a match in a ventilated module, the artificial wind forces a draft. The flame leans into the wind. It stretches out, trying to mimic its earthly teardrop shape, but it still retains its ghostly blue hue. Picture the flame fighting the artificial breeze, a delicate balance of physics and engineering. It is a beautiful dance, orchestrated by human ingenuity in the depths of space. Beyond our solar system, let us close the matchbox and look out the window. We are moving beyond the space station. We are traveling past the moon, past Mars, past the edges of our solar system. We are venturing into the realm of exoplanets. These are worlds orbiting distant stars. Each one is a unique laboratory of physics. What would happen if we struck our match on these alien shores? The rules of combustion are dictated by the atmosphere, and the universe is full of infinite, strange atmospheres. Worlds of pure oxygen. Imagine descending onto an exoplanet enveloped in a dense, oxygen-rich atmosphere. Here, the air is thick and heavy. The gravity is immense. If you were to strike a match here, the result would be terrifyingly spectacular. The abundance of oxygen would turn the tiny spark into an explosive roar. The match would be consumed in a microsecond. Picture a blinding, white-hot flash. The fire would burn so fast and so fiercely that it would melt the very earth beneath it. It is a world where fire is an aggressive, dominant force. The methane giants. Now let us travel to a different kind of world. Imagine a cold, hazy exoplanet with an atmosphere made entirely of methane. Methane is a fuel on Earth. We burn it for heat. But on this alien world, the sky is made of fuel, and there is no oxygen. If you strike a match here, what happens? Absolutely nothing. Without the oxidizer, the spark is just a useless flash of heat. Picture yourself standing in a sea of flammable gas, unable to light a single spark. It is a profound cosmic irony. The reverse fire. But there is a twist to the methane world. What if you brought a tank of oxygen with you? If you release a stream of oxygen into the methane atmosphere and ignite it, you create a reverse flame. Instead of fuel burning in an atmosphere of oxygen, you have oxygen burning in an atmosphere of fuel. Picture a flame that seems to burn inside out. It is a bizarre, alien fire. It defies our earthly intuition. It shows us that the universe is far more creative than we can ever imagine. The heavy atmospheres. Consider an exoplanet with a crushing, heavy atmosphere of carbon dioxide, much like Venus. The pressure is 100 times greater than on Earth. The heat is unbearable. If you strike a match here, the spark is immediately smothered. The dense carbon dioxide acts like an impenetrable liquid blanket. The fire cannot breathe. Picture the match head crumbling under the immense atmospheric weight. The environment is so hostile, so overwhelming, that the delicate chemical dance of combustion is instantly crushed. The cosmos can be beautiful, but it can also be brutally restrictive. The thin air of Mars. Let us return closer to home, to the red sands of Mars. The atmosphere here is thin, just 1% of Earth's pressure. It is mostly carbon dioxide. You strike the match. The result is similar to the vacuum, but slightly different. The friction creates heat, but the thin, suffocating air instantly snuffs it out. There is not enough pressure to sustain the heat, and no oxygen to feed the reaction. Picture standing on the rusty dunes, striking match after match, watching them fail against the cold, thin, alien wind. It is a lonely, quiet landscape. The cosmic scale of fire. We have looked at tiny matches, but the universe has its own kind of fire. Let us look up at the stars. Stars are often described as burning spheres of gas. This is a poetic myth. Stars do not burn like a match. They do not use oxygen. They do not undergo chemical combustion. They are powered by nuclear fusion. The crushing gravity at the core of a star smashes hydrogen atoms together to create helium. This releases unimaginable amounts of energy. Picture the core of a star, a place of pure, blinding, roaring pressure. It is a completely different mechanism of light. The illusion of burning stars. This is why stars can exist in the vacuum of space. They carry their own fuel, and their reaction does not require an oxidizer. When we say a star is burning out, we are using an earthly metaphor for a cosmic event. The star is simply running out of hydrogen to crush. Imagine the quiet, slow transition of a star over billions of years. It is a grand, slow-motion ballet of physics. It makes the quick flare of a wooden match seem like a fleeting, microscopic illusion. The rarity of earthly fire. As we journey through these alien concepts, a profound realization begins to dawn on us. Chemical fire, the kind that dances on a match head, the kind that cooks our food and warms our hands, is incredibly rare in the universe. It requires a very specific, very delicate balance of gases and gravity. Most of the universe is entirely devoid of fire. Picture the vast, dark stretches of space, completely untouched by the warm, flickering yellow light. Fire is not a universal constant, it is a localized anomaly. The miracle of oxygen. The fact that we have fire on Earth is a testament to the unique history of our planet. The oxygen in our atmosphere was not always here. It was breathed into existence by billions of years of microscopic plant life. Without life, there would be no fire. The match you hold is a product of biological history. Picture the ancient cyanobacteria slowly filling the sky with the breath of fire. When you light a match, you are participating in a chemical reaction made possible only by the ancient life of our world. The harmony of the elements. The universe is a vast symphony of extremes. There is freezing vacuum and crushing gravity. There are toxic atmospheres and nuclear furnaces. But here, on this tiny blue marble, the elements have found a perfect harmony. The gravity is just right to pull the cold air down. The oxygen is just rich enough to feed the spark, but not so rich that it consumes the world. Picture the delicate balance of our ecosystem. It is a fragile, beautiful bubble floating in the dark. The return to Earth. Let us slowly begin our descent. We are leaving the bizarre exoplanets. We are leaving the silent vacuum. We are re-entering the blue atmosphere of home. Feel the comforting weight of gravity returning. Hear the gentle rustle of the wind. The journey is ending, but the perspective remains. The next time you strike a match, you will not just see a simple flame, you will see a rare, miraculous event. You will see a delicate dance of physics and biology, made possible only by the unique embrace of our home planet. You are grounded, you are safe, you are home. As our cosmic journey gently comes to an end, we find ourselves back where we started. But our minds have traveled across the infinite dark, witnessing the ghostly blue spheres of microgravity and the strange, silent skies of distant worlds. We have learned that a simple match is not just a tool, but a magnificent expression of Earth's unique balance. The universe is vast, cold, and immensely beautiful, yet the warm, flickering glow of a flame remains a rare treasure belonging to our home. Thank you for traveling with us through the tranquil vacuum of space. If this journey brought you peace and a new perspective on our universe, please subscribe to the channel, leave a like, and let the cosmic algorithms know you enjoyed the ride. Now, tell us in the comments below, if you could safely stand on any planet in the universe and look up at the sky, which world would you choose to visit?